So we are in yet another Scope community meeting, and today we have Satyam, Akash, and Brian. Brian's gonna do a little live demo slash presentation on performance profiling on Scope. So Brian, please take it away.
Yeah, you know, when you mentioned slides, I thought there are a couple from talk I gave earlier in the year that I might use, but it's taken too long to pull those up. So let me just start. I'm going to share my screen, this one. Okay, so can you see my terminal window?
Yes, Brian.
Yes, I can.
Great. Okay. So I have the Scope repo checked out here. It's as at July 28th on master. And so the basic topic I'm going to talk about, which I think was the question, was how do you run the benchmarks and how do you go from there to performance optimization? Is that pretty much the right topic area?
Yes.
I recall, I don't know if it was Satyam, but somebody asked for something in those lines. I recall that.
Yes, right, Fons.
Okay.
It was, yeah.
Well, let's get going, and you can shout out if you want to hear different things. Yeah, so there are a number of benchmarks in the code already, so that's the easiest place to start. And so you can start somewhere simple, like in the report directory. Let's first of all, let's talk about, so the main thing we're going to do is going to use the GoTest tool. So if I simply run GoTest, it's going to run all the tests and tell me if they passed or not. I actually don't want to run any tests. So I use the -run flag, and then I give it some kind of string that doesn't match any actual tests. So that's going to run the GoTest command, but not run any tests, because what I want to do is I want to run some benchmarks. And again, I give it a pattern that matches a regex that matches. So dot will match everything. And off we go. So this is the GoTest command running benchmarks, all the benchmarks it finds in this directory. Let's take a quick look at one of those. Let's look at the last one, node set merge. Can you still see my screen? You see the source code now?
Yes, Brian.
Okay, actually, latest map merge. Let me just flip over again. So latest map merge was this one. So here's the source code. So the basic pattern of a Go benchmark is very similar to a test. It takes this parameter testing, except instead of a T, it's a B. And the B has a N parameter. And in a benchmark, so we do some setup. And oops, there we go. We do some setup, and then we reset the timer, and then we run the actual benchmark, and we run it the number of times given by N. And back at the run, so basically what happened is GoTest ran the test, and it timed it, and it said, well, that's really fast. I'll run it again a few more times. And it actually did that multiple times until it got to a number of 5,000 iterations. So basically N is 5,000, and it timed that as 300,000 nanoseconds, or whatever that is, 0.3 of a millisecond. Is it? Maybe I can't count. Anyway, it's 300 microseconds. Yeah, that is 0.3 of a millisecond per operation. so that's some benchmarks in there. This one is really fast. It got up to, like, it ran that 1 million times before the whole thing just took 1 second. And all these parameters are configurable. You can look that up in the help text. I don't know, something like this. So we're not going to talk about all the parameters right now because you can look them up yourself. Right. So we've run some benchmarks. The next thing that I usually do is I tell it to add the memory measurements, which are off by default, but here we go. So what it's doing is it is printing out a couple of extra numbers. It has measured the number of bytes allocated per operation and the number of actual allocations per operation. And as you'll probably see, garbage collection drives the speed of scope quite, or the slowness, if you like. Garbage collection is one of the biggest overheads that we have. So the rate at which you allocate bytes is the thing that drives how fast it's going to have to garbage collect, because the amount of memory being used by the process goes up and up and up, and then has to garbage collect, and then it goes up again. Yeah,
you probably have that in mind already, but I think it would be really good to illustrate this by a profile, CPU profile, in which it shows the garbage collector.
Yeah, yeah, exactly. That's what we'll do next. So so I'm just going to say that's how typically how I work when I'm trying to speed the thing up is I run the benchmark, and you can, instead of saying run all of them, you know you can put in the name of just one, like that. Run the benchmark, look at the numbers, change the code, run the benchmark again, and just make sure the numbers are getting better. Another thing that is interesting is this number is not very stable. So this time here it was like 4 something. This time here it was like 2 something. We're running on my laptop, which is going to speed up and slow down as it heats up or cools down. There's a bunch of factors that can impact the actual time, whereas the memory numbers are much more stable, you know, within a few bytes and exactly the same number on allocations. One thing you can do is run it more than once. So tell GoTest to run the same test 5 times. And then you get a bit of a flavor for how those timings vary. So, you know, based on those numbers, this 4 something something number was some kind of outlier. Anyway, I look, the timings is kind of a guide, and maybe it's interesting to see the range, etc., etc. But I really tend to focus more on these numbers, which are much more stable, the memory numbers. Okay, let's get an actual profile. So now we're going to go in the other direction. I ran the whole group of tests. So 50 iterations, 5 times. We're just going to run it once and profile that. And let's take away the bench mem. And so we're just going to tell GoTest to do a CPU profile. It takes a parameter which is where it's going to store profiling information. The output one, basically it samples what's happening very quickly in your program, and that's all going to go in this file cpu.out. So let's run that. So that ran, you know, took a little bit longer than these runs, but not much. The CPU profiling doesn't add much overhead. It has written a 9K file, so that's pretty compact, not too much. So how do we look at what's in this file? So now we're going to use a different tool. This is called pprof for Performance Profiler. And this again has a bunch of options that you can look at in the help text. The main thing that we're going to do is we're going to tell it one other thing to look at. We need the program. We need the profile data. And we need the program itself. So the program is helpfully left in the current directory. This is this is actually GMT UTC. A couple of minutes ago, that's the actual test program that we ran, actually built by GoTest, and it leaves it lying around in the current directory purely for this purpose. So we're going to run gotool pprof, and we're going to give it that program, and we're going to give it the file that came out. And you can run this interactively, and you can type commands in there. I can't remember. It's too much to remember, so I just always do it on the command line. So first thing you can ask it for is the top listing, and then there'll be a bunch of them. So let's just cut that off after about 20, 30 lines. Okay, what is this telling us? So let's start at the top. This is the command that I ran. It tells me it looked at report.test. It's a CPU profile. When did I run it? The thing ran for a second and a half, and we've got CPU covering slightly more than that. So maybe there was more than one thread running. One thing to watch out for is if this thing wasn't actually running, if the CPU was off somewhere else, you're not going to sample. You're not going to get samples. So that's one thing to watch out for. Actually have a reasonable number of samples. And then I asked for the top consumers of CPU. So we come down from the top. What have we got? We got something in the message pack codec, memmove, and each one of these has a percentage. So this one used 7% of the CPU, this one also 7%, and the cumulative of this and everything below it. That may be a little bit difficult to imagine if you've never done this in detail before, but basically the whole thing is conceived as a tree. You actually get it to draw a picture of the tree, but I find those pictures very hard to read. So I always do it on the command line. Anyway, the thing you're interested in is what's at the top of the list. And I did the benchmark, just scroll back slightly. The benchmark I did was a message pack decode. So that's what shows up at the top, decoding. These ones I recognize. So basically malloc scan object heap bit set. They're all to do with garbage collection, and so is this one, this external code. It's off in the runtime, running the garbage collector. And so if you add up the cumulative of just of those 3 lines, you get to about 25%. There's a bit more here, get to about 30%. But that's not telling you the full story. The garbage collector, the way it works is it scans all the way across memory. And that has the effect of kicking things out of the CPU cache that you are quite you would like to use. And so the impact of garbage collection is much bigger than the numbers reflected here. This is in the whole program. This is where we measured it, somewhere around 30%. But if you were to half the amount of garbage being created, the program would probably go twice as fast. Because this 30% number is like after the whole thing has been slowed down simply by generating a lot of memory and having a very bad effect on cache. Those are pretty detailed points, but I do want to emphasize the biggest, even though these things are like number 5 in the list, very much a factor bigger than that. If you take out the garbage, it goes faster disproportionately. So that was the dash top. That's the top down, the individual routines that use a lot of CPU. The other way you might want to look at it is cumulatively. And so we basically start at the whole decode routine and come down from there. And these individual routines didn't use any CPU, but you can sort of see, we kind of at this 80% figure all the way down to here, and then it breaks down into string latest map and string latest entry, and then there's something else going on which is not on this list. But basically, if you can't see individual routines that are interesting to optimize, then the cumulative view lumps things together, and you see maybe something pops to the top that looks interesting at that level. Maybe let's pick a different benchmark to run, because this one's very focused on the message pack stuff, which is in a library that's very, very difficult to let's just pick one of those. Latest map merge. So every time I run the go test command, it's going to overwrite, unless I change the name here, CPU.out, it's going to overwrite that. So if I go back to my profile, it's now got different things in it. So now, here's my benchmark, and it ran. Here's garbage collection again. Anything runtime, malloc, GC worker, GC, all of this is garbage collection. Basically the whole page is garbage collection for that test, with the exception of, let's do it without the cumulative, just look at the individual routines, pop to the top. So this one is the top one of our code, and cumulatively it's only 34% of the measured runtime. This is in the list. If we want to drill in a bit more detail, like drill in on one function, ironically, we ask it to list the function, like a source code listing. And all of these things that I'm putting in are basically regex matching. So it doesn't matter if I miss out part of the string, as long as it's reasonably unique. And I don't want to truncate the output of this one. So this is a source code listing. And on the left, we have time attributed to this code here. And on the right, we have timing attributed to this code plus anything that it calls. So look for the big numbers, basically. What's going on here. It's calling append, so that's some kind of memory allocation again. Maybe a copy. There's another append. This one is just a string equals, basically. I've chosen a pretty trivial function. There's not a huge amount going on. So all the time is spent in trivial things. If you want to look at what this thing called, one way to do that is peek. So here's my function that I just asked about. The one above it, or anything above it, is what calls this, which is basically my benchmark. And anything below it is all the functions that it called. So this is basically how append under the hood is implemented by a thing called grow slice and a thing called typed mem move, and there's that string compare. So this is what I do. It is possible to get this stuff spat out in a bitmap or a graphical view, but when you do that in the whole scope program, it's just so complicated. I never use it. Basically, I only ever use these functions that I'm showing you. Right. So I've run benchmarks. I've taken a profile. I've looked at the top N listing. I've looked at the cumulative listing, and I've printed out what goes on. I've gone on and on and on about memory allocation. So let's just, how do I actually drill into memory allocation? Let's go and just run the profiler in a slightly different mode. So instead of CPU profiling, I'm going to ask for a memory profile. So there we go again. It's pretty fast. I got a memory profile file. Yeah, it's really small. Maybe it's not going to tell me very much. So we're going to do basically the same profile command, except we're going to look at the mem.out file. And I'm going to ask it to print out the allocated space. So there are 4 options. Space, meaning how many bytes. Space and objects, meaning how many blocks of memory, how many structs, whatever, strings. And then whether we want to see all of the memory allocated for the whole run, or whether we want to see what was left over at the end. So you're running a benchmark, you really don't care what was left over at the end. And bytes is the thing that drives memory allocation. Garbage collection. So alloc space. I've probably spelt that wrong. I can never remember if it's an underscore or a minus sign. Here goes. Okay, there you go. Right. So in this whole run of the program, and it ran 5,000 times. Well, actually, it ran like once, and then twice, and then 10 times, and then it ran at some number like that, which actually adds up to like 7,000 or something like that. It ran up to 5,000 times, and this top guy allocated 1.5 gigabytes, and this guy allocated 260 megabytes, and no one else really allocated any memory to speak of. I can do the same list command, mem.out instead of CPU.out. I got nothing. What did I do wrong? Oh, I need to say, every time I need to say alloc space. So there you go. That's where the memory went. Of that number, half of it went in this initial allocation. Actually 1/3, and 2/3 went in this case. So that's kind of interesting, actually. There's a merge operation, and we're sort of guessing that the output of the merge is the same length as the input, but it turns out a lot of the time it isn't. Well, in this benchmark, anyway. Yeah, this is a good reminder. Don't trust benchmarks. Run profiles against the real program. I might come back to how you do that. Okay, so I think that's all the raw data on how do you run benchmarks and how do you run profiles. Any questions at this point?
As such, no questions, Brian. Only thing I wanted to ask, like we saw that there is a third-party library, right? which was consuming more time, CPU time. So how
Yeah,
do
in the message pack decode, that is true. Yes.
right? So how do we tackle this? Like because we don't have the control of that library.
Yeah. Well, fundamentally, if you find a better way to do it, you can submit a PR to that library, and if there's a big disagreement, it's certainly possible for us to build with a fork. But just because something is the biggest consumer of CPU, that doesn't mean you can make it go faster. That particular library is pretty well optimized, and it's just that the benchmark was benchmarking decode. So that lets me make a slightly different point. There are some bigger benchmarks. So I went into the report directory where it's deliberately kind of micro benchmarks. In the app directory, we have some benchmarks that render entire. Well, actually, we can go to halfway stage. We can go to the render directory. In the render directory, there are some synthetic benchmarks that run the rendering operations, which, as you can kind of tell from the fact that it's not just popping out the results the same way. In fact, slightly worried at how
it's pretty big and complex.
Is this one complex? Okay. Well, while that one's running, the point I was going to make about the app directory is it's got. Okay, there you go. Oh, okay. So that one took a long time because it's so simple. Because what it had to do is it tried running it like once and it was really fast. So it ran it 10 times and it ran it 100 times and it kept going. And eventually it managed to wind the number up to 300,000. That's actually why that took so long. In the app directory are benchmarks which will run the rendering process on actual reports, which it will read from files. Now, in order to run those, you have to have some reports from files, which is pretty easy for us because we got about 1 billion of them. Not entirely sure where somebody else could get them from. I guess if you can probably get the app to save them. Anyway, that's left as an exercise for the reader. I have this handy directory with some reports that I saved in December 2017. There's about 40 here, which are gzipped to 100K. So that's a substantial amount of data. And let me just remember how to spell this. Yay. Okay. So so this one, for instance, unmarshalling, the app benchmark programs take a parameter minus bench report path. So that's where it's going to tell it to read these files that I have stashed away. And actually, let's do that one with benchmem. So that one took a lot longer. And in fact, it only ran it once because one run was more than a second. And one run allocated 188 megabytes. So now we're kind of much more chunky territory. Let's do the memory. Well, let's do the CPU profile. See what I mean about the runtime varies quite enormously. So the let's just ask it for the top functions. The test program is now called app.test because we were in the app directory. We were in the report directory before. CPU.out and truncate it. So that's just to show you, you know, the message pack decoder comes in at like number 8 or something like that when you put it in the middle of a bigger benchmark. Decompression comes in above that, and this stuff is saying garbage collection to me. I'm not 100% which ones exactly are, but you know, scan and gray and malloc, those are all from the memory allocator and then this external code. So yeah, certainly most of this is garbage collection, and which is, I'm like a broken record. The number one driver in this whole thing is garbage collection. The codec stuff does show up. You know, it's certainly, you know, again, we're running the unmarshal code, so you'd expect it to show up. I'm not saying it cannot be optimized, but I have looked at that extensively, and short of some fairly major structural things, it's not going to get a lot better. Yeah, it's actually more effective to look at architectural changes in the report format, which is a very painful thing to do because we have to figure out backwards compatibility. But it's much more effective just to think about ways that we don't have to send certain data than to try and do better than this library, because it's pretty well optimized. But yeah, it's an interesting question. I'll give you that. Any more questions, or did I, you know, stuff I just didn't quite cover what you were hoping for?
Yeah, actually, this is from my side. I will ask you more questions once I dive into these things. But yeah, this is really helpful information.
Okay.
Yeah.
So I think I mentioned last time, I think we probably put the link to I gave this talk at FOSDEM where I kind of covered a lot of the high level stuff about why is garbage collection so important. I didn't do so much of the detail about how to run these tools, but the video on the slides are up if you want to. And if I didn't put the link in the last note, then we can put it in once we finish this time.
Yeah, sure, Brad. I'll search for it and put it in the doc.
Great.
Yeah, thank you.
Okay, next subject. Oh, let me stop sharing my screen. So, yeah. I saw Fons went off camera. Have you stepped away or?
Okay, so.
No, Fons is still there. Okay.
Yeah.
What's next on the agenda?
Next is like I'm going to just talk about the snapshot proposal, which we are like I was supposed to bring this week, but when Akash and we spent time on that, okay, So we realized that the Kubernetes snapshot is still in the alpha stage. Okay, they don't have the full implementation for the volume snapshot in the Kubernetes. For example, we saw that some abnormalities were there, such as they treat volume snapshot as a CRD, and it would be like helpful for us if it is a part of the entry, Kubernetes entry. So that's the one thing. Other thing was, we could not find the client set for the volume snapshot CRD, because scope architecture, like we need a client set to get all the objects, right? Because we have the client.go in the Kubernetes, pro Kubernetes, so which expects to have a client go client set. Okay, so should I okay,
I guess I'm not familiar enough with the details of the storage stuff, but it sounds plausible what you're saying. There's
Yeah, me neither, unfortunately.
oh sorry, I didn't get you.
I just said me neither. I'm also not very familiar with the storage side of things.
Okay. So that is why, like, I had dropped email to Prashant to bring someone from Portworx to discuss. But I think we will have a separate call with the Portworx on the storage support, because we are like we have started the implementation for the remaining part of the snapshot, and we will be submitting that PR to the Kubernetes external storage, okay, which is out tree plugin for the volume snapshot, and it will take some time for that plugin to go into the entry. Okay, so meanwhile, if we want to keep that code into some external repo and then bring it back to the view scope, or or put it in the view scope itself, so that decision, like that is the next decision. But first decision is how we want to proceed. So I think I'll do one thing. I will schedule call with the Prashant and his team, and then we will come up with the final thing, like what we want to have in the view scope. Make sense?
Yeah, it does.
Okay, cool. So you may know, like Uma had put one slide just in the beginning of the development when we started. I could actually show you some slide, like how we want to have it, the snapshots. Okay. Can you see the screen?
I can.
Yep. Yes.
Okay, cool. Now, okay, wait. I think you can see the slide, right?
Yes.
Okay, cool. So, actually, this is a pretty old slide. You can see currently this part has been, persistent volumes part has been moved to the pods. Okay, and we have added some extra filter to show the storage and hide the storage. And we have this overlay here, right? So we want to add a control, okay, such as this. This is just example purpose. Where if we click this, user should be able to take a snapshot for Kubernetes volume through scope. Okay, and snapshot is nothing but it is just a snapshot other PV object, okay, which will be created and that will be shown here. Okay, and if you then again, like, we can create a clone out of that PV that snapshot. Okay, so new PV will be created. So this is like a fun workflow. First take a snapshot, and then as and when user want, he can actually clone that PV and just bring it back, so like that. And we put it like controls. Okay, so we are like exploring like how to add the controls and all, because we have to add some basic controls to the storage objects. Currently it is not there. That support will come into like next 15 days or so. in the like we will send a PR for the controls of storage objects. But this snapshot control, this is what we wanted. This is like very helpful for the user. He won't have to go to the log into the shell and do the kubectl apply for the snapshot YAML and all. He can like user should be able to do it from the
so
UI
the motivation, the end user functionality, I'm totally happy with that.
Yeah.
It might just be where your mouse cursor is sitting, but when I look at your shared screen, it's over where it says CPU and memory, and I would think the controls will end up down about an inch from there, where it's those blue.
Okay. Sorry. I think I didn't share the complete part. Sorry for this. Okay, now.
Yeah, that's where the buttons. Yeah, that's where the control is going to be. Yeah, so that's all great.
Yeah.
So now I've forgotten what you said the problems were.
Problems were, in view scope, we currently expect that, for Kubernetes to have the client go, and we actually, fetch the REST config and we create the client set out of it. And then we have a long switch case for that to select all the Kubernetes objects, and, that will return the REST interface. So thing is, in the volume snapshot CRD, client set is not there. Okay, they have not generated the client set and put it back into the Kubernetes incubator external storage where all the snapshot code is kept. Okay, that is the first problem, but we were able to generate the client set for that particular CRD. But the problem in front of it is, like, if we want to add this support today for the view scope, where should we keep this client set? Okay, should it go inside the Kubernetes external storage? If we want to put it there, then that PR, actually there is already one PR existing, but they are taking a lot of time to review the existing one. On the top of that, then we may have to send our own PR there. Or other thing is, we can host it somewhere in the third repository on the view side, or in the in any side, and then add the dependency for that in the view scope. Or otherwise, third option can be like we can have the whole client set inside the view scope for the time being, until that volume snapshot becomes the part of Kubernetes entry plugins. So that will be a Kubernetes resource, and support for that will come from the client go inbuilt in the future. But I don't know, like, time frame, how much time it will take.
Okay.
I'm not sure I get the full picture though. But I think we agreed on writing a design document a few meetings ago.
Yeah, right. That's right, Fons. So I will come up with that. I actually got stuck at this problem, because even if we write the design doc today, I was worried about the problem, whether we are, we want to wait for that Outtree plugin to go inside the Kubernetes or not. Okay. So
okay.
Yeah,
I don't think that's a blocker. I mean,
okay.
I guess we have to take it case by case. I mean, I wonder if there's another approach, which is just to deal with the JSON, like not decode it into a hard struct. But whatever. I mean, up until the point where you try and paste in 100,000 lines into the scope repo or something like that, I don't think it's a big deal. Okay. And if you come up with a convincing reason why you need those 100,000 lines, then maybe we'll do that.
Yeah, the dependencies we have already for Kubernetes are huge. So.
Yep.
Yeah, what might be more tricky is if it has a conflict or something like that. But I mean, those just seem like technical details you got to work out. If you need to fork client Go, or if you need to add a separate library, just make a PR doing that, and as far as I can think, the main red lines would be like if it's truly humongous, like big, massive amount of code being pasted in, or if it causes something else to stop working, that'd be more of an issue.
All right. Other thing is, Brian, if we bring that code, client-side code into the view scope repo, it will, it has a cyclic dependency on the external storage repo, which is the place where, snapshot code is maintained. Can you see my screen? So basically, this is the snapshot proposal for the Kubernetes. It's kept in the Kubernetes incubator. Okay. So here we have the snapshot. All right. Basically, this is the place where we keep all the volume plugins for the Kubernetes, such as Gluster, NFS, OpenEBS, and all. Okay. I'll go to the snapshot. This is the CRD. Okay. So every cloud provider has to implement this, implement a snapshot controller along with the snapshot provisioner. Okay. So these two things are on the side of the vendor, which we don't need to care, because all we are going to do is we are going to follow some, we will make a call to the CRD only. Okay. So CRD will handle that part. Thing is, here we have a snapshot, right? In the snapshot, we have the client. In the client, they have only generated the REST client. Okay, so there is only REST client present, and there is no client set present as of today. Okay, if we go to the scope and we have probe Kubernetes, and we have the client.go. Here, you can see that we have the client which is using the Kubernetes client set. Okay, but we can actually, for CRD, we can have one more client for CR, and that will also be a client set. And the reason why we are stuck is, in this particular client end type. Okay, so let's say I add one more entry here at the bottom of this. That case volume snapshot, then I need actually this client set first of all. Okay. So this is not there today.
Yeah, well, like you say, you can maybe just add another member, so you just explicitly have the REST client, because that's what these things are returning anyway, isn't it? They're returning a specific type of REST client.
Yeah, exactly.
Yep. So that is one thing. Actually, there is already a PR present here, but which is not being actively reviewed. Here they are adding the version client. So if we were to add, so we will have these many changes. And I don't know, they are waiting. And this PR also, we reviewed, it has some flaws. They haven't taken care, but if at least this gets merged, then our way is very very simple. And the one other way is, if we put all this code in the view scope, still also it will bring this dependency into the view scope. And in order to generate the version client, we actually need to change the types inside that storage CRD. Okay, so that is how Kubernetes client generation works. They have not followed a proper way to write those particular types in this CRD. So all these things are concerning me. So that's why.
Yeah, well, I hear you. Maybe, for me personally, getting some code running is pretty important, because there's a certain set of things that you can see might be problems, but you kind of need to get beyond the things that might be problems and get to the things that really are problems. And well, maybe you're there already. I mean, do you have all this running in your fork in the OpenEBS project?
Yeah.
Oh, you do.
Including
well,
the dependencies and everything.
Yes, yeah, that will include all the dependency and everything. So,
All right.
yeah, the other question was like, as a view scope, will we be, good to have the OpenEBS dependency in the view scope? Okay, because we really don't want to put anything specific, or having dependency is a different thing, but anything specific to the OpenEBS should not go with the view scope, because that won't be a generic.
Well, yeah, but if it's like if it's for the purpose of reading the generic snapshot, or handling the generic snapshot object, I don't mind that.
Yeah, yeah, then fine. Like that we can do. We can maintain a different branch in OpenEBS repo. Basically, we have the fork for this also, external storage. Okay, but we'll have to maintain a different branch because we'll have to change the types in the snapshot in order to generate that version client.
Yeah.
So we did a small POC around this. We were able to generate the client set.
So it's getting a bit. There's too many
Details.
Yeah, too many details for me to figure out in my head. If you have a branch somewhere, you can send us send a PR, or you can send the GitHub compare two things link, and that way we just get a concrete view on what it is that you might be talking about. I mean, I see all these points you're making seem like valid points, and I think you're saying the whole thing's going to clean itself up in 3 months or 6 months or something. So, I don't know. We're just trying to be helpful within those parameters.
Yep. Okay, I'll do one thing. Next meeting, probably I will come up with the POC. We already had planned this. We will put, we'll fork this external storage into OpenEBS, and we will get this snapshot stable first. Okay. Stable as in we have to change the types. Once that's done, we'll generate the client set, and once we have the client set, we will include that dependency into view scope, and we will implement this volume snapshot CRD. So,
okay.
Yeah, that should be the way. That will be the way, basically, until we have this inside the Kubernetes itself.
Yeah. It sounds okay. I need to see the detail on screen. Yeah. So put something together, create, maybe like create a separate library just for the minimal pieces that you need.
Sure.
Yeah.
Yep. Okay. That's it, basically.
Cool.
Right. Okay. Unfortunately, we ran out of time to go through the issues on the PRs. We have 4 minutes left, and I'm not sure it's worth going through them. So maybe we should.
I put in a request to be a maintainer.
I approved it.
Oh, you did?
Yeah.
And there's one I forgot to re-review. I just asked for a comment, and as far as I can see, that one's 3260. Looks okay. I'll just have another read over it when we finish here, but I think that one can go in.
Sure.
Yeah. Anything else? I don't do scope every single day. So if I'm the bottleneck, just ping me on Slack, or pinging me in GitHub is less effective because I get so many emails from GitHub.
Same here. I have another full-time job, so I get a gazillion GitHub emails from there. So I really don't have the bandwidth. So if you need me explicitly for anything, please ping me directly on Slack, and I'll be responsive there. I promise.
Yeah, sure. Same here also. We are available all the time.
All right.
Cool.
Okay, great. Great meeting. Thanks very much.
Yeah.
Yeah.
Thank you.
Thanks a lot.
Thanks,
Thanks
Brian.
a lot for the presentation, Brian.
Yep.
Thanks, guys.
Bye.
Bye.